Hey guys, and welcome to this session on type hints. Now, these were introduced back in 2014 in PEP 484. I'll make sure this is linked down below. So if you want to go check out the rationale kind of discussion around this, and yeah, feel free to do so. The link is just there. Now, type hint is something I've been using for a fair number of time now. I think generally since this come out, I've been trying to use these as much as I possibly can. And I think in general, if you're wanting to go into the industry or go and work somewhere professional, type hints are pretty much expected. So if you're not using them, I'd really highly recommend learning how to use them. And to be honest, it's one of those things where once you use them properly, it's really hard to go back to a time where you didn't use type hints. So just kick things off. Suppose you've never seen a type hint before. Let me show you kind of why I think these are a good idea and why not using them is a terrible idea. Now, suppose we had a really simple function. We've got def add. This takes in A and B. Oh, sorry, let's make this a touch bigger. There we go. And we're returning A and B. Now, we might know what this is doing because we wrote it. But now, suppose you're coming to this for the first time. This is someone else's code. It's like, well, hang on, what are A and B supposed to be? I have no idea. Even if you open this up here, VS Code's saying that A can be anything, B can be anything, returns anything. Yeah, I don't know whether that's amazing or terrible, depending on how you see it. I don't think it's a good idea because we don't know what A and B are. And we don't know what it's returning. So what if this function is being returned into something which is then used for some kind of computation? Just simply saying, oh, yeah, it can return anything. Not really Pythonic. I don't think it's super smart. And it's a nice way to then introduce bugs into your code. So this, terrible idea. The idea of a type hint is that we say, for a given function or method or even just variable, this should be this type. Quick caveat as well. Type hints don't actually get enforced. They're not seen as rules. Of course, that's why they're called hints. Suppose if they were enforced, they'd be called something else. But these are type hints which are there to kind of guide us as programmers to say, hey, this function takes in this. This is what type it should be. And by the way, this function can also return this. Here's what type this is going to be. I do want to introduce Mypy today, which is basically a way of doing type checking for us, which is really nice. So let's kick things off, go ahead and just run pip install Mypy like that. I've already got it installed, so mine will take a second. And then all you got to do is do Mypy and then the name of your file. This is called typehint.py. So I run this, there we go. No issues found in one source file. So I want to show this sort of at the start when doing the first couple of bits here. And what I want to do for the rest of the video is start off really simple, just show you how some basic type hints work, and then go through a couple of kind of common use cases. So for these latter ones here, these are probably use a bit less than kind of your basic type hints. But I want to show you how these work, what they do, and how they can be helpful for your Python development. Let's kick things off with a really basic example. We can do type hints just for generic variables. So suppose I want to define name. I want to define is equal to James here. Let's do age. Not 100, but anyway, there you go. And there we go. So we can define variables like this, right? However, what if you want to make it explicit and say, actually, this name variable, I want to be a string during its lifetime. And age, yeah, that can be an int for the rest of its lifetime. So even though you could technically change this, if you pair this with Mypy, you get, Python gives you some stick if you try and change it, which is quite good. So suppose I went ahead and did name plus equals 100. Now, you might do this at the very start of your code, and then like 100 lines later, you've gone and done this. You might not necessarily spot it, and you might only find out you've done this when your program breaks. But however, if you run Mypy type hints, there we go. Mypy has come along to the rescue and said, hang on, line 20, something's gone wrong. In this case here, it said unsupported operand types, string and int. It's recognized that I've tried to do this to this, which is quite nice. So generally, I think Mypy is a good thing to have to kind of run through your code periodically. Make sure you aren't doing anything blaringly obvious, such as this here. Mypy can come in a lot handier as well when we look at things like function type hints and method type hints. But yeah, this is the simplest possible way you can do it. We can define variables, and then this is simply saying, this variable, I want to keep it as a string. So if other developers come along and use your code, it just gives a nice kind of simple indication as to what this variable is going to be and what you want it to be. Now, where this really comes into its own is when we start to define functions. So let's define area. And area takes in height and width, and it gives back something. We'll come to this in just a second. And if I just did return height multiplied by width here. Now, a good way of kind of showing the immediate power of type-ins is to go ahead and call the function and observe what we get here. So we can see VS Code has told me that height is anything, width is anything, and it gives back anything, and that's, yeah, pretty poor for the time being. Let's suppose for now we just want these to be defined as integers. So we say height, colon, space int, width, colon, int, and then the way to do this bit is to make a space here, little arrow, and say what you're returning. There we go, much nicer. So we do area, open this up, and now Python's going to tell us that I want height to be an int, width to be an int, and this to be an int. So, you know, we could quite easily come along and do 10 and 2. So if we run this now, here we go, 20, it all works fine. Of course, this can still go wrong. So if I run this here, we've got, yeah, it's not broken, but it's not the result we wanted, is it? We could do Mypy, type int before running, and Mypy will flag this up now, so check this out. Argument 2 to area, argument 2 is this guy here, has an incompatible type string. Okay, so Mypy has picked up that this has got into here, and that's not good. That's not what we want. You know, you could do 22. Now suppose our function changed and did return the area as a string. We'll rerun Mypy. There we go. Return value is string. We expected an integer. So Mypy is going to pick up on these things for you. So yeah, whilst it's not like a strictly type checked language, if you combine type hints with Mypy, you can make your Python code just that bit better, that bit more professional, that bit more controlled, that bit stricter. So it's super nice, it's nice and simple to do, and generally my workflow will be write my functions, my methods, and as part of my general linting, so I normally use rough for linting, there's a full video on that on the channel if you want to go check it out. It's really good to bring in Mypy into that as well. Just let Mypy run through your code. You can run it through a whole module or package, it's fine. And just see if Mypy picks anything up, especially if you've defined a ton of functions, a ton of methods, and you're doing lots and lots of calls to them. Mypy might just pick up something that you've missed. So yeah, pip install it, go ahead and use it. It takes a second to do. Now then, we've done type hints for variables, super basic, some basic function arguments and their return types. Now what if we want to bring in sequences of items here? So let's kick this out for just a second. This one's nice and simple, but we do need to bring in the typing module for this. So we need to say from typing, this is built in, so don't worry about installing it, and we'll do list. Now suppose we have a function which takes in a list of somethings, right? Let's suppose we have a function called square all, and maybe this takes in a list of, I don't know, it could be a list of floats. So let's do LST. And now this is going to be list, and let's do float here. And we're expecting this to also return a list of floats like that. Just something to bear in mind, we always do this in title case, and if we're doing like list, tuple, dict, whatever, this is going to be in square brackets always. I'll do an example after this, but just something to bear in mind for now. Okay, now suppose you want to return, let's do a list comprehension. Let's do I to the 2 for I in LST. So now let's go ahead and call it down here. We'll do square all, and we'll pass in 1.2, 3.4, 5.5. Okay, there we go. And now let's run Mypy. No issues at all. That's good to know. Type hints, and there we go. Nice. Just to recap, in this case we have said it's going to be a list of floats. This here is going to be a list of floats as well. Now let's take this one a step further. Let's also bring in the dictionary one as well. Now suppose you wanted to make this return a dictionary comprehension. So suppose, for example, you want a dictionary to have the format like the first number can be a float, and then it'll be like this here, and maybe you want to return the float as a string like this. Bit of a strange comprehension, but just to kind of show the idea of how this would work. Let me first do my internal kind of comprehension here. So we'll do I as the key, and then as a string, split this out a bit, we'll do I to the 2 for I in LST. Now, let's just quickly run Mypy through it and see how unhappy it is. There we go. And now, see what it's got here? Dict, float, str. Basically saying I got back a dictionary with a float up front and a string in the back. So what you want to do is basically change this around. So I'll do float here and str there. That's basically meaning a dictionary with floats for keys and strings for values. So if you run it this time, it should be happy. There we go. It is. Looks nice. So we can run this and hopefully see if we get the correct result. And we do. Nice. So again, I'm just kind of reiterating this, and I've said it a few times. This is just a nice, simple way to make sure that our functions basically behave with its inputs and behave with its outputs here. It really kind of comes into its element with bigger, really kind of larger programs that have tons of modules, tons of classes, methods, functions. Mypy can just kind of go through it and make sure that the function's taking in what it says it is and returning what it says it will return. Nice way to kind of remove the risk of bugs later on. Of course, bugs can still happen. You could just return the wrong data, but using type hints and Mypy, it's a nice kind of first defense against some really silly bugs. So next up, let's take a look at how we use any and optional here. Now, generally, the idea of any, I'm not super keen on using. Let me just remove this for a second here. Here we go. Now, if you remove this type hint altogether like this, and let's do print area here. If I remove this and open this up here, VS Code has inferred that this is going to be an integer, which is okay. However, what you can do, if I do from typing, remove and put this here as any, so I've got rid of list and dict and put that in there, and we can go here and say any. There we go, that's fine. Or not fine, depending on how you see it. Let's bring this back to open this up. Now we're basically saying this takes in height, width, both integers as before, but this time it's going to give back any type. Now I don't use this super frequently, but this is a potential way of saying here's a function that can, in this case, return any type. Whether you want to use that in your code is completely up to you. But in this case, this is saying expect anything back from this. Same with these guys. In this case, we can even say width can be anything. So height, integer, width, whatever you want, return whatever you want. So whether you think that's a good idea or not, it's up to you. But the typing module gives us the option to do that. And in this case, it's fine. It's not too bad. The one which I think is a bit safer than this, I mean, there's nothing quite as dangerous as that, but is the optional one. So if we do optional here like this, scroll back down, and if I do optional, do this and do as an int here. Let's also do optional, and we'll put that as an int as well. I'm just going to quickly remove this just so you can see these come back. Now, when we do optional, we're basically saying, let's move this out of the way. We're basically saying this could be an int or nothing. So we're kind of giving the chance for this to be nothing at all or something. So if you open this up here, that's like the union operator. So in this case, height has to be an integer. In this case, we're saying it's optional. So this could be an int or nothing at all. And this function can return an int or nothing. So this is not as quite as rough as using any, but it's still probably not ideal. You're probably using this in situations where you might have like a data class and you're not perhaps sure what a particular thing might be, but you think it might be an integer or a float. So to show this, we'll do from data classes, import data class here. We'll make a little class called person, and we'll decorate it with the data class decorator here. So we've added name here, and let's just do string, and let's perhaps go ahead and do, imagine we didn't know height. Height could then be optional int like this. So that's kind of where you could do this, I suppose. You could even make it as a default thing like this. So you could say actually it's equal to none for the time being, but name is expected. So if we then did a is equal to person, like this here, let's go ahead and see what we get. So name string, that's a given. We have to do this one here. Now let's go ahead and hit run. Get no errors, and that's absolutely fine. If we go ahead and print a, hopefully it comes out. Person, yeah, name John, height is none here. And now that's because we've done like equals none. If I got rid of this, it's going to kick off because we haven't done this like equals none here. So if I was doing this in practice and I think, okay, height may or may not be required in this class, I could just go ahead and do this here. So that's a nice simple way to use optional from the typing module. So up next we have unions, and this is where a type can kind of be like one or the other. So let's clear this and take a look at a simple example that uses union. For this one, let's keep it really simple. Let's just do multiply, and suppose we're doing some item. We'll come to this guy in a second, and it's always being multiplied by x. And we'll say x is going to be integer here. Now suppose the thing we're passing in, it could be a string or an integer. Of course, you can multiply both. They'll just have vastly different results. What you can do is actually say from typing, import union like this. And then what we do here is say union, pass in some square brackets, and then pass in the things here, which item could be. So maybe item could be a string or an int, could be a float, you could, that's fine, you can do that. But in this case, yeah, we'll stick it as being a string or an integer here. And this is then going to give back, same thing really, could be a union of string or an integer. So depending on what item is, depends on what this is going to be. So we could then just do return item times x like this here. Now then, if we were to then go ahead and do a call to this, we could do multiply, open this up here and see this little pipe operator. That's basically the union operator. Item can be string or an int, x is only an int, but this could return a string or an integer. So we could do x 10 like this here, and then naturally let's go ahead, take this, stick this on the line below, and then pass in 50 like this. So if we do this, we'll run it, that's absolutely fine. Let's do this here, and no issues as well. Whereas, of course, if this union thing was gone, and this was just like string and string, yeah, it would kick off on this one because we've passed in a type which it wasn't expecting here. It's the union bit that's basically telling Python, this is fine, this can be one of these two things here. So in this case, if you're writing a function or a method, something that is potentially going to be having one of two types of import or one of more, whatever, union is the way to get around that. You simply write union, of course, make sure it's imported, stick in some square brackets, and then put in the possible types in here as well. If you do that, you're good to go. But generally, of course, I would always kind of err on the side of caution about creating functions that can take in multiple different types and give back multiple different types. I think in this case, though, it's a fairly small basic function, so we can kind of get away with it here. The next one is something called a type alias. So I'm going to quickly remove this, get rid of this here, and do type alias here. Now, suppose we had some kind of function where we're always greeting people. So we'll do greet, name, well, it's going to be a string here, and we're then going to give back a string as well. So we can do return a nice f string, and we can just say hello, blank like this, populate this guy with name here. Now, suppose we were passing in lots and lots of different names here, and we want to refer to the things we're passing in, not just as a string, but as something more specific. And I suppose these were like people's names or employees. We can basically set up a type alias to tell Python that we're doing so. So we can be a bit more specific and a bit more context specific about how we're using this function. So in this case, we'll do employee like this, and we'll say type alias equals str. This now means we can switch out str for employee like this. And now we go ahead and call this, let's do print greet. It says name employee here. So it's basically like a custom way of doing typing here. It's not going to be something that you're going to be using every day, but I think it's a nice way of making your program a bit more personalized, a bit more fun, and I think it looks quite cool as well. So we're saying employee is of type string, but it just means that whenever we use the function here, we can say, actually, it's employees being passed to this. So go ahead, John here like that, run Mypy. Mypy is fine with that. What is cool actually, say if I did some numbers in here instead, it still kicks off because it knows that employee is an alias for string. So if you pass it something that isn't a string, Mypy is still aware of that mistake, which is quite cool. So I pass in John again with exclamation mark, that's fine, no issues, all good. And when we run it, you see that it works just fine. Now for this next one, I want to take a look at callables. Now this is something that's probably a bit more advanced, but you're generally going to be using this if you're working with things like decorators or higher order functions or whatever. Anything where you're passing a function to another function and your outer function is going to be using it. So let's just do my example here. I keep this really basic because it is a bit more of a tricky one, this one. And to do so, we're going to need to do a couple of different things. So I'm going to keep this blank for the time being, but I'm going to go ahead and do def add and just keep this as absolutely as simple as possible. So you want to do two integers, x as an int, y as an int here, and this is going to be returning an integer. So we'll get this done and leave it at the top here. So that's my kind of function that I'm going to be passing in here. It couldn't be any simpler than that. X and y returns the sum. Now what I want to do here is say this function is going to take in a function. So let's do sum func like this here. We're going to say sum func is going to be a callable. And what we do inside this is you kind of pass in this kind of double list structure here. And the first set defines basically what this is. So it's going to be an int and an int. So we'll do int, int, and here we do int like this. So this is where it gets a bit tricky, and hence why I've done this as simple as possible. We're telling this function that your job here is to take in a function. This bit is saying that function you're taking takes an int and an int, gives back an int as well. What we then need to do is define what else this function takes. Let's suppose this takes two more values. Let's do value 1, that could be an int. Let's do value 2, this can also be an integer, and going to give back an int. Yeah, that's quite long now, isn't it? So yeah, probably glad that I kept this one nice and basic. So now we'll do return sum func and do value 1, value 2. There we go. So now we can call this function, and let's just, before we do so, recap what we need to pass in. So this function takes in sum func, we'll pass in this, value 1 and value 2. We'll just pass those in place. So we can do print my example, add, and then we'll do value 1, let's do 10 and 5. Let's run that. 15, that all works, looks good. But is Mypy happy? And it is indeed, looks good. Of course, if this was str here, it should pick this up now as well. Yeah, again, pretty cool, isn't it? Even though like we called this function, but Mypy has still gone in, checked out like the internal function we passed in. It's happy that this has gone wrong somewhere, so it's reported that back to the screen, so we can now go back and debug it. And by debug it, just change it back to int, and it's all good to go. Up next, we have literals, and these are really nice actually. There we go, let's do literal here like this. Okay, now suppose in this case we're writing a function, and rather than just saying this takes a string of some sort, what if you wanted to be really particular about what actual string we can take in? So suppose in this case here, we want to greet people, but only if they have a certain name. So we can do name, normally we'd do str like this, and return a string, but rather than just saying any name as long as it's a string, what if you wanted to say, okay, maybe this can only be one of two names? What we can do now is replace this with literal, open up some brackets here, and we can say John and Sue, like this. And now we can say return, I think we'll do an F string as we did earlier, and we'll do hello, name like this. So it's basically like doing the str one, but being way stricter about those actual strings it's taking in. So we can do hello, and let's do Adam here. Let's run Mypy through it. There we go. So it's saying we expected John or Sue. Actually, we got Adam. We didn't like that. If we go ahead and change this to John, now Mypy should be happy. And we can probably go and run it as well. Let's see that one. Hello, John. All works. So just like the previous one, it's not something that you're going to be using all the time, but it's a really nice way to make it so that you can say this function takes in one of n specific values. You don't have to pass it in like here. You could define this as a list somewhere else, pass that list in here, and it would work just the same as well. So just to reiterate the main points, I think if we use type-ins and Mypy together, it can be a really nice, powerful way to make our code a bit more secure, makes it generally a bit cleaner. And one thing it can definitely do is dramatically reduce the risk of writing buggy code. If your program is huge, you've got a few hundred lines of lots of function calls, Mypy can just kind of blast through all those function calls. And as long as your type-ins are correct, if you've done something incorrect here, Mypy can nicely say, just like this one here, it can nicely say, actually, a way you've called your function is incorrect. Cheers for watching, guys, and I'll see you all in the next session.